Suppose a truss is subjected to the following loads, and it undergoes some deformation, so the deformed shape may look something like this. And suppose we want to find the deflection of this truss at node E. Well, similar to the principle of virtual work that we derive for the beams, we apply our virtual load at node E where we want to find the deflections. So effectively the real loads are making the virtual load do work, because the virtual load does not make the truss deform. And therefore the external virtual work is the virtual load multiplied by the real displacement at node E. And that's equal to the internal virtual work due to the deformations of the truss members. And recall when we did an axial force analysis, we found that the deformation of one of the truss members, being a bar, is equal to the internal force in that member by the length of the member on the axial stiffness. So therefore for one of these bar elements, we can give them a subscript I. And we assume that all the truss members have the same axial stiffness, so the same area and the same Young's modulus. So therefore the work done to deform a truss member is simply the internal force in that member by the deformation. So that'll be Fi by length I on AE. So similar to the beam, we had the unit virtual load causing virtual bending moments to develop in a beam, but in this case this virtual load causes virtual axial forces to develop in a truss member. And multiplying this virtual force by the deformation in each truss member gives the internal force in member I by the length of the member on the axial stiffness. And then summing this over all the truss members, so I equals 1 to the number of members, gives us the total internal virtual work due to the deformation of the truss members. So as we mentioned, the external virtual work is equal to the internal virtual work. And here we can go a step further by assuming that the geometric and material properties of the truss members are the same, so we can take out the axial stiffness outside the summation. Please subscribe, like and comment to help me reach more students.